Welcome everyone. In this video lecture, we will solve a numerical based on Zener diode and it is from the Microelectronics circuit book. So first of all, the question is partial specification of a collection of Zener diodes are given below. Okay. Some specification of a Zener diode is given. Okay. So we have to identify the missing parameter. Okay. So basically here three a specification of a Zener diode is given, we have to find out the fourth missing parameter and its corresponding value and estimate its value where VZK means the knee voltage is somehow equals to the VZ node. Okay, that VZ node and this one is simply the IV curve of a Zener diode we can say. So here we can see this one is the knee current and corresponding voltage. Okay, and this one is the voltage. Okay, minus VZ node and the corresponding current is a minus IZT, some test current, and this slope. Okay, that is our del V equals to RZ del I, where this slope will R1 by RZ gives the dynamic resistance or sometimes say the incremental resistance of a Zener diode. Okay, so this one, so it will better. I have to draw the equivalent model. Okay, means if this one is our Zener diode. Okay, ideally we are making like this, but if we have to make the equivalent model, we have to do like this one is very fundamental one. Okay, plus of minus vz, and this will be the vz node and rz, and this will be some test current, say IZT, or sometimes it is IZ. So if we write the Kirchhoff's voltage law, one can write Vz minus Vz naught minus IZT into RZ. Okay, where simply we can write Vz. This voltage is the sum of Vz naught plus IZT test current into RZ. RZ is the dynamic resistance or incremental resistance. So this one is the basic. Okay, so in the picture in this one, uh, I'm not going to discuss more about this simple Zener diode concept. So in the question, okay, again I am writing the first part of the question. Okay, then we will solve. So in the question, we have to identify the missing specification. Okay, we have to identify the missing specification. So basically, this one is our Zener diode. Okay, so Vz is given, there are some Vzk is given, and in the question it is also mentioned the Vzk is somehow equals to Vz naught. Okay, Vzk is very near to Vz naught. I have made like this as a larger picture, but if we plot very ideally, means this should be like this. Okay, I and V for just I have make it enlarge, okay, to just see what are the points here. Okay, so in the question it is very clearly mentioned Vzk equals to somehow Vz naught. Okay, so here we can say, and this Rz is the dynamic resistance or incremental resistance, and if this Rz value is low enough, so this Vz will be approaches to the Vz naught and it will be better for the voltage regulator. Okay, in some separate video I will discuss this diagram everything in more detail. Okay, so now Vzk is somehow equals to Vz naught, so we have to go for this equivalent model. Okay, so from here we can say the Vz equals to Vz naught plus IZT into RZ. Okay, RZ, so here RZ is missing in this one. simply we can say the RZ, that is our dynamic resistance or incremental resistance is missing. Incremental resistance of the diode is missing and it is generally in the ohm or 10 of ohm. Okay. So RZ we have to find. Okay. So first part is this, the missing specification we have to identify from all these five questions. Okay. Then after we have to assume that assuming that the power rating of the breakdown diode is established at twice of the test current. Okay. So for the power rating we have to make the diode current as a twice of the test current. So we have to find the power rating. So that part is also we have to solve. So first here the RZ is the missing one. The okay, and it is from the microelectronics circuit book. So we have to find the RZ value. For the RZ value, what we have to do, this RZ, okay, is simply we can write VZ minus VZ naught by IZT. Okay. So now the VZ value is already given. So just simply write 10 minus VZ naught is same as that of VZK. So 9.6 and test current is 50 milliampere. So I am writing like this. So this one will be 0.4 by 50 into 10 to power 3, or if you make it, if you remove this decimal, 500. So this would be 40 by 5. If we solve this one, it will nearly come 8 ohm. So RZ value will be 8 ohm. Okay. So first part, the missing one, that is our, this one is the incremental resistance. Incremental resistance of a diode. Okay, so in your diode, Zener diode, better to write Zener. Okay, Zener diode. Okay, so this one is one specification. So RZ we have find from this one. So this one is very important equivalent circuit model of a Zener diode. Okay, this should be plus or minus. We can write on. Okay, so this should be 8 ohm. Okay, now we have to focus about the power rating. Okay, for the calculation of power rating, it is clearly mentioned in the question that assuming that the power rating of a breakdown diode is established at about twice the specified test current. So now we have to take IZ is twice times of IZT in every question. So now for this one IZT is given 50. 50 milli means 100 milliampere will be we have to take. Then after we have to find the corresponding Zener voltage, that is our VZ. So then again we have to use the same formula, VZ equals to, or just we have to write this as a VZ equals to VZ naught plus, basically we have to write IZ into RZ. Okay. So the VZ naught is given 9.6. So we have to write it 9.6 plus, now this IZ will be your 100 milliampere, not 50. Okay, because for the power rating calculation we have to take the twice of the specified general current. Okay, IZT. So it should be 100 milli. So 100 into 10 to power minus 3 I am writing, and RZ we have calculated it 8. So if we solve 9.6 plus 0.8, okay, after simplification, clear. So if we solve this one, it should be 9.6, then 10, then 10.4. So this should be our 10.4 volt. Okay. Now the power rating, that is our P will be our, simply in this case VZ into IZ. So VZ into IZ will be, VZ is our simply now 10.4. So make it 10.4 into IZ will, you have to take 100 milli, 10 power minus 3. Okay. So or one more line I am writing 10.4 into 100 into 10 power minus 3. Okay, or if we remove this decimal, 10 will come here, then 1040 by 123. Okay, it means 1.04 watt. You can solve. Okay, so the power rating become power rating. The VZ IZ value will be 1.04 watt. Okay, so this one is a very simple one. Means when this value is given, okay, we have to take this assumption. Then after RZ will be the missing link. Okay, so we have find the RZ value from this one, this expression. Okay, then for the power rating, the diode current, Zener diode current, is the twice of the specified test current. Okay, so make it 2ZT every time, 2 times of IZT. Then we have to find again VZ, the Zener voltage at that particular current, diode, Zener diode current. Then we have to find that. Then we have to use power rating VZ into IZ. So it should be this. Okay, so this one is the first part. Okay, so now we have to go for the second part of the question. First part we have already solved this this one. Okay, now we have to go for the second one, B part. So B part again, very same procedure we have to do. So okay, so what I am doing, okay, so I have already copied the question. So second part, okay, so this one is the second part of the question. Again, so the question is this, so we have to find the missing link. Okay, so again, we can directly use the formula, or once again I am just writing the plus of minus vz naught rz I z t. Okay, this one is z and this one is just for our this plus of minus vz, this is equivalent circuit. Then as we know, we can write simply vz equals to, so every time I will not write, but this time I am writing here rz IZT into rz. Okay, clear. So now again the missing parameter IZT is given, VZ is given. Okay, so we have to identify the missing one, that is our VZ naught is now missing. This VZ naught is the missing one. Okay, so one can easily write the value of VZ naught from this one. VZ naught will be Vz minus IZT into RZ. Okay, I am writing here. So Vz naught, Vz is given 9.1 volt. So 9.1 minus IZT 10 milliampere. So 10 into 10 to the power minus 3. The resistance value is 30. Okay, so what we have to do, 9.1, and if we solve 10 into 30, 300. So this should be minus 0.3, so it should be 8.8 volts. Simple calculation. VZ naught is now known to us. So in this case, VZ naught is 8.8 volt. Now we have to do for the power rating. Power rating. So again, power rating, the IZ value will be twice times of IZT. Okay, twice times of IZT in the question is given. So it should be 2 into 10 milli, means 20 milliampere. Okay, IZ. So now we have to find out the corresponding VZ. Okay, so every time you have to find this one. So now VZ naught plus IZ into RZ. So VZ naught is value is 8.8. Write it very carefully. IZ 20. So 20 into 10 to the power minus 3 into RZ is 30. Okay, so then after this Vz is our 8.8 plus 3 into 600 into 10 to the power minus 3 means 0.6. We can say this one is 8.8 plus 0.6, that is our 2, then 9.4, 9.4 volt. Simple calculation. Okay, now Vz is known, all this thing is known. So what we have to do, power rating, for power rating P equals to Vz into Iz. So Vz is our 20, sorry, 9.4, no? 9.4 volt into Iz, 20 milli, 20 into 10 to the power minus 3. If we want to solve like this, you can write 94 into 2 means 8, 188. 188 into 10 to the power minus 3. So simply write milliwatt. So power rating will be now 188 milli. So this one is our part 2. Part 2 question. Okay. This one is our B part. Okay. So now it is a very simple one. So now the second part we have already solved this one. This also. Second part we have solved. Now we have to go for the third part. This third one. Okay. So again, RZ is given, VZK is given. So we have to first identify the third part. Okay. Control V. Third part. So I'm just taking this third one. Okay. So this one is our third question. So first we have to, again I am just showing the, we have to find the missing parameter, okay, missing parameter and estimate its value, okay. So three things are given. Again we have to start with the fundamental. We have to start with this formula. I am not Vz equals to Vz naught plus Iz Rz. Okay. So here Rz is given, Vz is given. Okay, Vzk. So Izt is not given. Okay. So what we can do, Vz equals to Vz naught. Okay. So simply we have to find the Izt value. So Izt, okay, Izt, T here also better to write. Izt equals to Vz minus Vz naught by Rz. Simple formula. Okay, and we are solving. So it should be 6.8 minus 6.6 because this one is nearly Vz naught. It is already given. Okay, and Rz. Rz is 2 ohm. So it should be 0.2 by 2. Okay, so this should be our 0.1 ampere, or we can write it simply 100 milliampere. Anything we can write. So now we have to think about the power rating one. Power rating. Okay, again we have to take Izt. Iz value will be twice times of Izt. In the question it is given. Okay, so twice into 100 milli means 200 milliampere. So the corresponding Vz will be Vz naught plus Iz into, okay, a small rz, Vz naught plus Iz into R. Okay. So now Vz naught is known to us. So better to write 6.6 plus Iz is our 200 into 10 to the minus 3 into 2. So 400. So 6.6 plus simply 0. If you solve 200 in 200, 400 into, so 0.4. So 7 volt. Okay. Now we have to write the power rating. So this side I'm just writing power rating Vz into Iz. So Vz is 7 volt into Iz is 200 milliampere, means 1400 into 10 to the power minus 3. Okay, means simply 1.4 watt. Okay, so this one is the third part. Okay, now for the another part. Okay, for the say D part. Okay, okay, I will solve only D part, and I will write the answer for E. You have to solve that one. Okay, I will solve only the D part. Okay, and you have to solve the remaining one. Okay, now again very similar kind of thing we have to do. Okay, Vz missing parameter, so Rz will be missing. So again write Vz equals to Vz naught plus Izt into Rz. So Rz equals to Vz minus Vz naught by Izt. Okay, the Rz is missing, so Vz 18 minus 17.2 by Izt 5 milli. Okay, so if we solve simple by using simple calculation, means 0.8 by 5 milli. So if we solve all this thing, it will come around 160 ohm. I am not going to solve now. Now for the power rating, the Iz value will be twice times of Izt, means 2 into 5, 2 into 5 milli, 10 milli. Now again we have to find Vz, so Vz naught plus Iz into Rz. So Vz naught is simply 17.2 plus Iz 10 into 10 to the power minus 3 into Rz. Okay, Rz is 160. So now this one I will solve 16.2 plus 1600, 17.2 plus 1600 into 10 to the power minus 3, 1.6 means 18, means 18.8. Okay, 1.6 means 18.8. Okay, 18.8 volt. So the power rating here, power rating Vz into Iz. So Vz is simply 18.8 into 10 into 10 to the power minus 3 means 18 point, means 188 milliwatt. Okay, so this one is the another answer. Okay, like that also you can do for question number E. For the E I am writing the missing link will be Vz naught. Okay, it will become 7.2. For the power rating we have to find first Vz, it will come 7.8 volt, and if we do the power rating it will come 3.12 watt. So only this question you have to do, and all is very similar type of problem, but it is very fundamental one. So you have to do all these questions very carefully to solve this problem. And this is from the microelectronics circuit book. So thank you for watching this video.